Hi folks, in this section I want to spend a few minutes talking about the four fundamental forces in the universe that have been identified by physics. In a chapter on forces, it's kind of fun to talk about some of the wild, way out there modern things that are going on. About 30-40 years ago, it was discovered that there are four fundamental forces in the universe that govern everything. Everything from a stone falling down when you drop it, to nuclear reactors, to chemistry, all of chemistry itself. And these four fundamental forces are gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Now, this is a huge, massive topic, and we are going to just go through it at warp speed just to give you a little bit of a taste. Now, one of the primary forces is gravity. Gravity is the presence of matter causes space-time to curve. The question has been for a long time, why is there gravity? And the genius Albert Einstein, in his theory of general relativity, described gravity as causing space and time itself to actually warp and curve, and that is what makes one object fall next to another object. Now, this is a little wild and crazy because human beings are designed to actually experience motion in 3 dimensions, plus 1 dimension of time. And in order to visualize this well, we're just not wired to see into 4 dimensions or 5 dimensions. It's just not part of the human psyche. And so we use a lot of pictures like this to indicate an object that's sort of falling downhill, but it's curving into another dimension. I know, wild and crazy stuff. We think gravity is always attractive, never repulsive, but that is under review as we are talking about dark energy. And this class is not going to get into dark energy, but that we suspect has something to do with pushing gravitational or matter apart. The range on gravity, we believe, is very, very large or infinite. And here's the wild thing. It is the weakest of the 4 forces. Of the 4 forces discussed back here, gravity, electromagnetism, strong and weak force, even though this one has the name weak, gravity is the weakest of them. It's hypothesized that every one of these forces is transmitted by a particle, and the particle for the gravitational force is called a graviton. Now, at the moment I'm recording this, the graviton itself has not been discovered, but that is the name. They got a name for it when they find it, the particle that actually transmits the force of gravity. The other force that you are very familiar with in your everyday life is electromagnetism. If you have ever gotten a static electric charge and all your hair sort of stands on end, that's due to static electricity. But this word has electricity and magnetism as part of it. Well, electricity works so that if you have like charges, both negative charges, they're going to repel. 150 years ago, people were looking at that and said, magnets are the same way. If you have a north pole of a magnet and a north pole of a magnet, they're going to repel. And people started looking at this, and through time we've discovered that electricity and magnetism are very, very intimately related. The smallest possible magnet you can have is one electron that is spinning on its own axis. It will have a north pole and a south pole, just like a magnet. Now, electricity and electromagnetic forces can be both attractive and repulsive. So, as you know, a positive charge and a negative charge will actually be attracted to each other. A north pole and a south pole of a magnet will be attracted to each other. This attraction and repulsion is responsible for all of chemistry, the structure of matter. This is a diagram of a salt cube crystal, and sodium atoms are positively charged, chlorine atoms are negatively charged, and these electrical forces are responsible for all of the chemical bonding that occurs to hold you and I together, your food together, your home together. Electricity, magnetism, also light is controlled by this electromagnetic force. The particle that transmits it is called a photon. You're familiar with photons. Photons are little wavicles of light. And the electromagnetic force is very strong compared to gravity, 1 times 10 to the 39th times stronger. That is a lots stronger. How do we know this? Well, If gravity was stronger than the electromagnetic force, you would be a little pile of atoms that would be all sunk to the center of the Earth. But because of the fact that electromagnetism is stronger, the bonds that hold your body together are actually able to overcome the huge force of Earth's gravity. The third force is called the strong nuclear force. Now, the strong nuclear force is only within the nuclei. That's the only place that it manifests itself. It is the strongest of all of the four forces. And here's what it does. It does an incredibly important thing. We talked in the last slide the fact that like charges repel. If you have two positive charges, they're going to repel each other. Well, 100 years ago or so, people started looking at this and they went, so how the heck does the nucleus of an atom hang together? In an atom, you've got lots and lots of little protons that are shoved together in the nucleus with electrons whirligigging around the outside. Well, the electrons are attracted to the protons because one's negative and one's positive. But how do you cram lots and lots of little positives together in that nugget that is the nucleus? They discovered that there is another force, and this strong nuclear force has a very, very short range, but it holds the nuclei of atoms together. It is so many times stronger than the repulsive electrical force that it can hold nuclei together. Where do we see this strong nuclear force? Well, it manifests itself as energy in things like nuclear fission and nuclear fusion, which power the sun with nuclear fusion. Strong force, as far as we know, is always attractive, and the particle that governs it or transmits it is called a gluon, which was kind of a cute name because it's supposed to be the most strong glue, the strongest glue ever invented. The next force is the weak nuclear force. Of the two nuclear forces, this is weaker than the strong force, but it is still stronger than gravity. Gravity is still our weakest force. What's the weak force do? Well, a neutron is not a fundamental particle. A neutron can actually be broken into a proton and electron. So a neutron is neutral. It can be broken into a positive proton, a negative electron, and a little dude called an antineutrino. Now, when does this happen? Lots of different particle accelerators and cosmic sort of situations will make that occur. It has a very, very short range, only happens within the nuclei of atoms, and it's responsible for some forms of radioactive decay. If you've studied any radiation, beta decay is related to the weak nuclear force. The particles that transmit it are the positive and negative W particles and the neutral Z particle. These particles have been found using particle accelerators in the last 20-30 years. And so the weak nuclear force we understand quite well. 50 years ago or so, back in the 1970s, it was proposed, why are there four? What's so wonderful about four? And the idea was that maybe if temperatures got hot enough, energies got extreme enough, these four forces would actually become one. So we've got gravity, the weak, the electromagnetic, and the strong force. And as temperatures get hotter, these four forces, we believe, are going to morph into one big force. The idea is something like this. If I have a coin, and like a penny, and I am rotating it very quickly on a tabletop, at any instant, I can't tell if I'm seeing heads or tails. If you give an object lots and lots and lots of kinetic energy, lots and lots of speed, it will be indistinguishable between two forces. And as the universe cools down, each one of these is going to be separate. So if I have two pennies spinning, one might stop and I can see the heads, the other penny might stop and I can see the tails. But while it's spinning, it's going so fast, I can't tell the difference. This is the entrance to the Fermilab particle accelerator down in Batavia, Illinois. And this sculpture at the entrance to the United States' premier particle accelerator has this cool sculpture, and it's called broken symmetry. Because when this was broken, they had already shown that the four forces were actually three, and they suspect that the universe, as it has cooled, has created these separate, unique forces. So I think that's kind of a cool little artistic interpretation of physics. Back in the 1980s was the first time that we got two of the forces to be proven to be the same. The weak force and the electromagnetic force. If you get temperatures hot enough, how hot? 10 to the 16th Kelvin. That is crazy, nutty hot. Where can you achieve temperatures like that? In particle accelerators, like the particle accelerator at Fermilab and the particle accelerator at CERN in Switzerland. What they do is they take little tiny protons, they speed them up to almost the speed of light, smash them together, and the stuff that comes out is going to look something like this picture. And then by analyzing all the tracks of the junk that comes out when you smash particles together, they found evidence that these two forces were exactly the same thing. Now, it's believed that when the universe was created, right after the Big Bang, about 10 to the negative 12 seconds after the birth of our universe, that these two forces were combined because the temperatures, the particle density was so incredibly extreme. Current things that are going on are to look for the weak, the electromagnetic, and the strong force to be combined. That's something that we have not achieved at the moment I'm writing this video, and that is something that is being looked for at labs all over the world. One of the things they're looking for is proton decay. Remember I said neutrons were not a fundamental particle? Well, protons are made up of three little particles called quarks, and that these quarks will automatically pop out of a proton, but very, 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 very seldom. It's a very, very rare event, and it takes a very long time for this to happen. That's why the universe is so incredibly stable and matter is stable. But there are labs all over the world that are looking for this. Eventually, and I hope within my lifetime, there is hope that all four of the forces will be brought together in one force. This is the idea of the theory of everything. And it was believed that when the Big Bang occurred, all four of these forces were unified. They were sort of like four sides of a coin, and that this thing was spinning with such incredible speed that nature only had one type of force, and these forces cooled into the four that we know today. I know there's a lot of information here. I also understand that you probably didn't understand all of it, but it's just a taste, hopefully to make you a little bit curious about physics. See you later.